Okay, guys, we're going to talk about how to do these problems. This is the 6B, the standard for 6B. So if we're watching it before the test, these are designed to be similar to the problems that you might see on the test, but also just to review. And if you didn't do well on the test, then you'll need to take these notes and be able to show me these before you do the corrections on the test. Now, what we need to remember with this is that really what we're doing is the same thing we were doing before. If I had t minus 6 equaled 12, then what I would do is undo whatever was happening to the t. I look, and the thing that's attached to the t is the subtraction of 6. So the way I would undo that is I would add 6 to both sides. Well, when I look at this problem, the difference is it's got that scary monster of the fractions. And so when I look at this, instead of adding 6, I'm looking, and the 3/5 is what's being subtracted. So I'm going to add 3/5 to both sides. So this gave me 0, so I just have t. And then 2/5 plus 3/5 is 5/5. So t equals 1. And then I check it by plugging it back into the equation. T minus 3/5 is supposed to equal 2/5. And so then I'm going to put in that 1 was t minus 3/5 is supposed to equal 2/5. And then if I look at this, this is 1 is 5/5 minus 3/5, and 5 minus 3 is 2, so that's 2/5. This side's 2/5, this side's 2/5, so it checks. So my answer is that t equals 1. So again, we were doing the same moves as if we were using integers, but instead it had fractions, which is usually why most people get a little upset. So as we look at number 2, again, what I'm going to do with that is I'm going to do the same thing I did before. So what I said was, look, if I have 5 plus x equals 12, then what I would do is I'd want to get rid of the 5, so I'd subtract 5 from both sides. And then I get x equals 7. So when I look over at the problem, the thing that's attached to the x is the 3/11ths. So just as I subtracted the 5 from both sides, I'm going to subtract 3/11ths from both sides. And when I look at this, then what I have is left on this side, when I look at the left side, that equals 0, so I just have an x over here. And then over here I have, on the right hand side, I have 5/11ths minus 3/11ths, which means x equals 2/11ths. And then I check it. I rewrite the equation of 3/11ths plus x equals 5/11ths. And then I just plug it in that I have 3/11ths plus 2/11ths on this side. And that means I have 3 plus 2/11ths, which this side is 5/11ths. And this side was 5/11ths, so yep, they are equivalent. So my answer is that x equals 2/11ths. Again, we're doing the same thing we would if they were integers, but the difference is it looks scarier because it's a fraction. So if you understand the principles behind fractions, then you'll understand how to do this. That might be a good thing to review. So just if you're doing these things, you're gonna be fine as long as you just take a breath, think about what would you do if it was an integer, and then do the same thing. Okay, so when we look at this, again, if we were to look at this equation, 13.5 equals 0.27p, the scary part is it's got decimals in it. Because if I had 14 equals 2 times 7, or 2 times p, then all you would do to solve that is divide both sides by 2, because that's what's attached to the p is the 2. And it's being multiplied, and so we undo that by division, and you get p equals 7. So if I look over at this problem, the problem is these are decimals. And I can do one of two things. I can do the math and try and do the long division with it. Or I could look at it and say, well, I know this is 27/100ths p, and this is 135/10ths, or 13 5/10. Now, if I'm looking at this, then what I can do now is I'm going to divide. Because that's what I did over here was I divided. So I can divide both sides by 27/100ths. So I'll do the math over here to the right. If I have 135/10ths divided by 27/100ths, then what I'm going to rewrite that as 135/10ths times 100 over 27. And so now if I look at 135, that's going to be that's 5 times 27, and 100 is 10 times 10, and there's a 10 on the bottom and there's a 27 on the bottom. So the 27 reduces and the 10s reduce. So this is 5 times 10, which is 50. So that means that p equals 50. So if I check it, then I come over and say, well, I had 13.5 supposed to equal 0.27 times p, which means 13.5 supposed to equal 0.27 times 50, which if I multiplied 0.27 by 100, I get 27. This is half of that. Half of 27 is 13.5, but I can just do the math. I can say I have 27/100ths times 50 over 1. And then if I look at that, then I could see that this is 50 times 2, so the 50s reduce. And so I'm going to have 27 divided by 2, which is 13.5. So this side was 13.5 and this side is 13.5. So yep, they are balanced. So P does equal 50. Again, if we looked at what we would do if it was just integers, and we just think about the process that we would do with that, and do the same process even though they are decimals, make them into fractions, over 100ths, over tenths. If you're confused with how to make them a fraction, well, then we probably need to talk about that a bit. But come see me. But this isn't, it's hard, it looks scary because of the fractions. So, but we're going to do the same thing every time. We're going to undo whatever's happening to the variable. Okay, so again, if we look at this one, again, if I had 4 times D equals 12. Then what would I do to solve this? I would look at this and say, what's happening to the D? It's being multiplied by 4. How do I undo multiplication? I undo that by dividing by 4. I get D equals 3. So I'm going to come over to the problem and say, what's happening to D? D's being multiplied by 3/5. How do I undo that? I divide by 3/5. So I would divide this side by 3/5, divide this side by 3/5. 3/5 divided by 3/5 is 1, so I'm going to have 1D on this side. And then I have to look at 2 and 5/6 divided by 3/5. So the first thing I have to do is convert 2 and 5/6 to improper or a usable fraction. So this is going to be 6 times 2 because there's 2 wholes and it takes 6 to make a whole. So you have 12 6 plus 5 more 6, which is going to give you 17 6. And then what I'm going to do is change this to multiplication. And I'm going to multiply by the reciprocal. The reciprocal of 3/5 is 5/3. So, and I still have my D over here. So D equals, now I look at this and 17 is prime and 5 is prime and 3 is prime and 6 does not go into 17 or 5 does not go into 6, 17 doesn't go into 6. So really I'm just going to multiply across and I'm not going to be able to reduce this fraction. So what I'll have is 17 times 5 equals 50 plus 35, which is 85, and 6 times 3 is 18. So I'm going to have D equals 85/18, which if I look at that, 18, I go down the 18 column until I get to the number that's next to 85. So when I look down that 18 column, I go between 72 and 90. That's where 85 is going to be. So when I go to that 72, that's going to be 72 is 4 times 18. So this is 4, and then that makes 72 18ths, and then there's going to be 13 18ths left over. So this is 4 and 13 18ths equals D. Or 85/18 is an acceptable answer. As a matter of fact, I'm going to use that 85/18 to simplify or to check. So when I check, I'm going to plug in that 3/5 times D is supposed to equal 2 and 5/6. So I'm going to have 3/5 times, I'm going to use that 85/18 is supposed to equal 2 and 5/6. When I look at this, I have a 3, and then 85 is going to be 5 times 17. And then I had 5, and 18 is 2 times 2, 2 times 3 times 3. And this other side was 2 and 5/6. Then I look and see that means this reduce, the 3's reduce and the 5's reduce, which means I have 17/6 left over here. This side is still supposed to be 2 and 5/6. And if I look at 17/6, that's going to be 12/6 plus 5/6, because 12/6 is 2, and then there's the 5/6. So these two are balanced when I plug in 85/18 into D. So my solution is that D equals 85/18 or 4 and 13/18. So again, I mean, it looks scarier because it's fractions. That's the simplicity of it. If we did the same steps we would have done if it wasn't a fraction, it just takes more work. It's more complicated. So what we were doing before was with simple numbers. Now we're doing with more difficult numbers. And so if you struggle with fractions, you're going to struggle with this. So I would suggest you make sure you're brushing up on your fraction math too. Okay, here's one last problem. Now the difference with this one is something comes out negative. But again, like I said, if we took and we had 4 equals negative 2 times c, and we would look at it and say, well, what is happening to c? It's being multiplied by negative 2. How do I undo multiplying by negative 2? I divide by negative 2. I would have to remember that a positive divided by a negative is a negative, and that 4 divided by 2 is 2. And I would have negative 2 divided by negative 2, and negative divided by negative is a positive, and 2 divided by 2 is 1, so I have that c equals negative 2. That's what I would have done with an integer. If I look over here, the problem is on the left here that these are fractions. But the same rules are going to apply. I just have to apply a few more rules when I'm doing math with fractions. So if I look at this, this is going to be, I'm going to convert my fractions to be improper fractions first. So I'm going to look at this and say there's 2 wholes. It takes 7 to make a whole. So that's going to be 14 parts. Plus the 3 parts is going to give me 17 sevenths. Equals negative. If it takes 5 to make a whole, and I have 1 whole, we're going to have this, which is going to be 5, plus the 3 more is going to be 8. So I'm going to have negative 8 fifths times c. And if I want to if I'm multiplying, because that's what this is doing to the c, to undo that I have to divide, or here's another step we could use. We could just multiply by the reciprocal. If I look at what the reciprocal of negative 8 fifths would be, it would be negative 5 eighths. If I multiply both sides by negative 5 eighths, then what happens is on this side, I have negative 5 times 17 over 8 times 7. And this side winds up being negative 8 over 5 times negative 5 over 8 times c. And the 8's reduce and the 5's reduce. And a negative times a negative is a positive. So this is a 1, that's a 1. So 1 times 1 is 1. So I have 1c on this side. And then I can simplify, because now this becomes, nothing reduces here. 5 is prime, 17 is prime, 7's prime. Nothing reduces, so I'm going to wind up with negative 85, and 8 times 7 is 56. So I can keep it as negative 85 86, or 85 56, or I can look at that and say, well, that's the same thing as 56 56 plus negative 55 56 plus negative, that's going to be negative 29 56. So I'm going to have negative 1 and 29 56 equals c. Okay, so now I'm going to check. Now if I were to check over here, I just plug in negative 2 into c and see what I got. It's harder only because it's more complicated, because I have fractions. So again, I'm going to have 2 and 3 sevenths equals negative 1 and 3 fifths c. Now I'm going to double check this, make sure. I'm going to not go over and just trust my math from before. I'm going to double check here, and I'm going to redo it and say, well, 5 times 1 is 5, plus the 3 is negative 8 fifths times c equals equals 2 and 3 sevenths. And then I'm going to substitute. Again, we draw that line down the middle so you can keep things organized. Now I'm going to have negative 8/5. And we said that the answer was negative 85/56. So I'm going to plug in for C, negative 85/56. So when I look at this then, I've got the negative 8 over 5. And then I know that 85 is going to be 5 times 17. And I know that 56 is 8 or 2 times 2 times 2 times 7. So when I look at this, the 8 reduces, the 5 reduces. And that means I'm left in a negative times a negative is a positive. So I'm left with positive 17/7, which 17/7, if I look, I've already done the conversion over on the left here, but I'll just go ahead and change this. It's going to be 14/7 plus 3/7. 14/7 is 2, and then 3/7. And this side was already 2 and 3/7. Those are equal, so my solution is that C equals negative 85/56 or negative 1 and 29/56. Okay, so the difficulty is that you're doing fraction math. It's the same steps of solving any other equation. So this is a separate standard because we know the fraction math is what messes people up the most. So I hope that you get some practice with this. Good luck, and let's see you in cave time.